As promised, here's a slab design example. Um, it's based on an example from Design of Concrete Structures by Darwin Dolan and Nilsson. So go buy that book if you want to see this in more detail. So here we have a slab that's integral with its supports with just 2 spans and 15-foot clear spans. We're going to use the ACI approximate moments, and the appropriate one for that is this right here. There we go. And we need W to do that, so let's calculate the ultimate load. So it's 1.2 dead plus 1.6 live, and the dead is a self-weight. So we're going to have to first estimate the self-weight, and these are both exterior spans, meaning one end not continuous, and the minimum depth in that case is L over 28. These are 15 feet spans, 12 inches per foot, divided by 28. And that comes out to 6.4 inches. Let's say 6.5 inches. That's the a pretty good depth, and we'll try that. And so the dead load then, okay, 6.5 divided by 12 feet times 150 pounds per cubic foot, and that comes out to 81. So there we go, 81 PSF. And so the dead plus live is 1.2 times 81 plus 1.6 times 100. And that comes out to 257 PSF. Next, we will get these moments here. We are not using the slab approximate moments because those were applicable only for spans less than 10 feet, and we have 15 feet. And so, you just put LN is 15 feet, WU is 0.257 kip per foot because the unit tributary width is 1 foot. So Q equals W. And so if you do WL squared over 24, WL squared over 9, and WL squared over 14, those come out to, let me move this away, over 24 comes out to 2.41 foot kips. Over 14 comes out to 4.13 foot kips, and over 9 comes out to 6.43 foot kips. Okay. Next, let's check if this D is reasonable, if the thickness is reasonable. So D is 5.5 inches. And let's make sure that will be below rho max. In the end, I think we might be close to rho min, but let's check rho max. So I get rho max is 1.81%, and I'm going to spare you the details, but if you go rho to Rn, Okay, and then you do BD squared equals MN over RN. And then you go 12D squared equals MN over RN. You get D minimum to get rho max is 2.8 inches. So 6.5 inches is okay. And in fact, typically I worry about in slabs, are we going to be below rho min? But there's nothing we can do about, oops, sorry. So 6.5 for H is okay. D of 5.5 is okay. I'm worried more about rho min, and we'll figure that out when we get there. Okay, so let's continue. Okay, and so what we need to do for each of these cases is find out the area of steel. And so I'm going to call this A, B, and C. And I'm going to save some time by doing this in columns A, B, and C. So MU, 2.41 foot kips, 4.13 foot kips, and 6.43 foot kips. Okay, MN required is just MU over phi. And while I'm at it, I'm going to switch that to inch kips. Okay, well, let me find my calculator. So here we go. So the required MN is 2.41 divided by 0.9 times 12. 32.1 inch kips. $55.1 and $85.7. And then I'm going to do RN equals MN over BD squared, which is MN divided by 12 times 5.5 squared. Okay, so I'm going to take 85.7 divided by 12 and divided by 5.5 squared. That's 0.236 KSI. Let's see. Zero 0.152 KSI, and oh, this is very small, 0.0885 KSI. Okay, and from RN you can get rho, and I have this in my calculator, so I'm just gonna solve for that. Let me do that. Let's see, I need to double check F prime C and FY. I guess I didn't write it down. Let's say F prime C is 4 KSI. Let's just do 4 KSI and 60 KSI. That's how I got the rho max. Okay, so with that, and RN is 0.85. Solving for rho, I get rho equals, very small, 0.0001 150. Okay, let me just do this for the other two. 0.152. Solve for that. Solve for rho. 0.0259. And for this last one, for 0.236 KSI, solving for rho, 236, 0.0408. And then AS is just rho times BD, 12 times 5.5. Okay. So I get times 12. 0.269 inches squared. Zero 0.171 inches squared, and 0.099 inches squared. And these are all per foot. Okay, so then what we need to do is check that against AS min. So AS min for grade 60 is 0.0018 times B times H, and H, not D, so 6.5. And so the AS min is 0.140 inches squared. So finally, we need, let me add another page here. So we need 0.14 inches squared per foot. We need 0.171 inches squared per foot. And we need 0.269 inches squared per foot. Next, we have to go to a table and pick those out. And I'll do that in the next video. Let's see what's happening here. Delete that. Well, that's actually not in there. Okay, well, there we go. So we'll pick these steel out from an AS per foot table in a little bit. But for now, let's just summarize what we have. So let me copy this picture. And put it down here. Okay. I'm going to take this off to help us draw this better. And so what we need, let me put it in red. We need 0.14 inches squared per foot there on the top. We don't need these dimensions. We need 0.171 inches squared per foot on the bottom there. And we need 0.269 inches squared per foot on the top there. And in addition to that, we need a temperature steel going this way. And that temperature steel is this minimum 0.140 inches squared per foot. This is all per foot. So what I'll do in the next video is I have to go to a table and pick this out, and I'll make a sketch. So I'll come back with that video in a little bit.